So in this session, we are going to download Process Monitor and going to inspect our application. So one of the things so far was happening is we were looking at the static state of the client and server we are debugging. But that's going to change here. What we are going to look at is we are going to collect something like a video. Video in the sense that a continuous logging of the runtime of the client and server. That is what Process Monitor does. Previously, we've been looking at photos, if you will, static information. The information doesn't change as the time progresses. That's what we've been looking at so far. TCP view, netstat, a resource monitor, process explorer, all these tools we have been seeing so far only look at static information. But Process Monitor is going to collect continuous information, continuous logging of our API calls, our working of the program. Now, let's download it and see it ourselves. So the first thing we are going to do is stop the client and server. The server is running as of now, so I'm going to stop it. And I'm going to remove all these breakpoints. Here also, the client, I'm going to stop the client, and the client doesn't have any breakpoints. Now we are simply going to run the application, both the client and server, while the procmon is running. So next, what we are going to do is we are going to download Process Monitor or procmon. So again, simply search for Process Monitor download. You should get the first link like this. Like I mentioned, it's a very powerful tool. We are not going to cover a lot of details of it. We'll be sticking to the networking part of the Process Monitor. I'm extracting it right here. The icon, folder, everything looks very similar to Process Explorer, but it is a very different tool. So it'll ask you to run as administrator if you have not. So you can press reset here. Again, I'm not expecting you to do this demo by yourself, but feel free to do it. These are the steps. I have just started Process Monitor. Now, the tool itself collects a lot of data, so make sure that you don't run this tool for a long time. So it has so far collected these many events, almost 500,000 events it has collected in a short span of time. So it is collecting a lot of data, millions of lines of log. Because it is collecting the data from the entire system, not just the application we are looking at. We can apply filters, that is exactly what we are going to do, but otherwise it collects a lot of data. So the tool collects registry information from Windows, file, and network. This is what we are interested in. So if you look at the filters, so I'm filtering everything out, only the network is enabled. I can see the packets going in and out of this system right now. So there is this Firefox, these agents sending different information across the network. Now what we are going to do is we are going to understand what our application looking in the Process Monitor. Some of these things looks familiar to you. So receive, send, all that kind of things. So we'll see what we are going to find out about our application. As I was talking for some time, it has collected almost 1 million lines. So what I'm going to do is I'm going to do a clear so that it'll start from the beginning. Now I'm going to start the server. This time I'm going to start without debugging. I don't need a debugger to make things clean and simple. Again, the client also I'm going to start without debugging. Started without debugging. So everything done correctly. Both the programs ended. We don't have any breakpoints as you can see here. So immediately go and stop the Process Monitor. So this is how you stop the Process Monitor, this capture button right here, or you can press Ctrl E. So this will stop capturing. As you can see, this number is not counting anymore. Now we are interested only in our Python application. So we need to filter these logs such that we are seeing only the traffic we are interested in, the action which is happening from our client and server. For that, we are going to see something called process tree. So process tree looks very similar to Process Explorer, but it is again something slightly different, in fact very different. I'm not going into the details of it, but what we are trying to do is to filter our Python. So as you can see, our Python right here, some of the Pythons has gone. They have ran only few seconds right here. So the child-parent relationship is there. So the way we identify our Python is again same thing. We look at the command line arguments. So I'm expanding this part of the command line argument. So the command is given right here. So this is not our server, it is some other lsp server.py. We are looking at our server, which is listenserver.py. This is a process we are interested in. So what I'm going to do is I'm going to right click and add process to include filter. Similarly, this is our client. Again, I'm going to add process to the include filter. So after that, you should be left with these many events, as you can see right here. So let's try to understand our processes. We have two Pythons. One is our server, another is our client. So the PID of the client is 704 and the PID or the process identifier of the server is 16360. So the big number right here. So this is server, this is server, this is server. Client, 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 server, server. So that is how the process ID looks. Probably you should not look at the python.exe because both are Python, you may get confused. So the application has ended. This is the time at which these events happened in the system. Now this is the path. This is looking familiar to us. S1, if you remember correctly, it was the local system or the local host. This is the IP we were passing, 127.0.0.1. So S1 stands for localhost. We have seen that inside different tools. Now, what is the first action which is happening here? It is the connect operation from client to server. How do I know that? Because server is listening on port 6542. And this is a random port, the random client port 61715. This is a random number all the time. This number changes. We have discussed that. We have not discussed why it changes all the time, but we have discussed it changes. Now here it is a server which is coming into the picture. Server is doing an accept. That is precisely what server should do. It is accepting the local port is 65432. That is our magic port, accepting the connection which is coming from the client. Then it is doing different send and receive back and forth. So the data transfer is happening from here to here. One of the things you need to be careful with process monitor is that if the events are very quick, they may not be a little out of order. Look at the precision of this clock. So this is very precise clock. So this is seconds and this is sub-seconds. The precision is too high to be accurate. I have seen that a lot happening in Procmon. So this amount of precision may not be that accurate. So what I'm saying is some of these events right now looking at could be out of order. So take it with a pinch of salt. But overall, we know what's going on right here. We are transferring data from client and server. That's what we did. So copy, receive, send, copy, receive, send. And we can see some length here. 12, 12, 12, 24, 24, 24. And send has some start time, end time. Like that, if you look at this, we have some more options right here. Now what I'm going to do is I'm going to double click on one of these events. Let's see what more we can find out. So these are more information about that particular event. It is a TCP connect event and it has these many parameters. A lot of these things are documented, a lot of things are not. Most of it is Windows specific. So we are now going to the details of it. This is the process which has generated that event. No surprise, it is our Python client. And this is the command line argument, which is our program right here. So it is the code from the Python which has created this. Now, if you look at this is something interesting. Now, before showing you this stack right here, what I would like to do is I would like to talk about setting symbols, especially if you are doing this demo by yourself. So in options in Procmon, just like in the case of Process Explorer, you have configure symbols. Again, I'll be providing you this particular DLL. If you want to install Windows Kits and WinDebug, this DLL will come along with it. But otherwise, as part of the training downloads, I will be providing you this DLL because installing all this stuff is pretty difficult. Everything else you can copy from here, just like in the case of Process Monitor. So if you don't have symbols, you will not see the stack like this. But if you don't want to do this demo, it's completely fine. I'm just showing you certain things in the operating system. How all these things works behind the scenes. That's what we are discussing, at least for the time being. So I didn't explain much about call stack. So call stack is, like the name says, it is the stack of function calls. If you go back to our code, this is our client code. So we have the connect here in our code. What is this connect doing? The connect is not really implemented in Python. So it is calling into operating system. We'll be discussing that shortly with the help of block diagrams. But for the time being, this connect is calling into the operating system. And there are a ton of operating system functions which are called one inside the other by this connect call. And that stack is what we are looking here. So this is a connect call which is coming from Python after a lot of Python stuffs here, all this language runtime things. In the end, it is calling the connect from this C++ or C library. So this is the WinSock implementation by Microsoft. In Linux, it'll be different. And then it switches into the kernel of the operating system. So this K right here is all in kernel. There starts something called the lower layers of the OSI in networking. So this is the AFD, which we have seen before, which is implementing this socket file object. And then the almighty TCP/IP.sys, which implements TCP/IP protocol in Microsoft Windows. Probably the single most protocol driver as far as Windows is concerned. Windows networking is concerned. A lot of TCP/IP Mac related details are implemented in this driver. We will discuss more about it in future, but you are right now looking at different layers of the OSI stack. We have not discussed what is OSI stack, but we will. At the end of the day, this is the implementation of this connect call we are doing at different layers of the operating system. So we'll see all these drivers in future, but I'm just showing you these tools can show you this kind of stuff. There is one more important driver, in fact many drivers coming on top of this called endis.sys. It is not shown inside Procmon because Procmon doesn't break there. Procmon is taking this event from TCP/IP.sys, so Procmon can't see that particular stack trace. So TCP/IP connect with something called endis, which is the physical layer driver of network interface cards in Microsoft platform. And one final thing I wanted to show you in Process Monitor is disconnect. So as you can see, we are not doing any disconnect inside our program. We have not seen something happening. So where is this code coming from? So let's have a look. So the Python is doing something without even telling. How is that happens? So Python has its own cleanup mechanisms, even though we have not written anything per se. It is doing close socket behind the scenes. As you can see here, both client as well as server is doing close socket. In fact, we should have done it ourselves, but either way, Python is cleaning up our mess. That is what is happening here, nd close. So it is closing that particular file and it is going all the way in the TCP stack. TCP deliver fin to client. That's a very interesting call. TCP deliver fin to client, plain English. we'll see what it is. TCP deliver fin to client. It has a lot of meaning to it. We'll see what it is. If you can remember this one thing, you will get to know when we reach there. TCP deliver fin to client. Let's see what client is doing when it is closing the socket. As you can see, there is no TCP send fin to client here. There is a reason for that as well. But again, without getting too much detail into any of this, what we can do is we can look at our final tool, which is Wireshark. So we are going to get one more layer deeper with the Wireshark. Wireshark is captured at the wire or the physical layer, just like the name says, and we'll see what's going on inside Wireshark. So that is all I have to tell you about Process Monitor. I know I skipped a lot of details, didn't explain many of the things which was there in the screen, but some of the details will come to you in the future sessions. So to conclude, we have looked at Process Monitor and we got a glimpse into the working of certain important calls like connect, accept, and things like that, how it works internally. We have seen the continuous tracing, what happens inside the operating system when our programs run. Very important point we have seen in Process Monitor. We'll dig into more details later of this trace we have seen. But for the time being, what we are going to do next is we are going to look at the last tool in our list, which is Wireshark.